Well, good morning. Welcome to Space Oddities. Thank you for joining us on this Saturday morning for our live coverage of the launch of India's first observatory to look at the sun, Aditya L1. And I'm joined this morning by the usual suspects, them being Daz and Michael. How are you both?
Hi there. Okay.
Oh, we're fine. Thank you very much. I'm very much a bit weary-eyed,
Yeah.
but I was up until the early hours, and now we've just come on to do this. So, yeah, it's. But I will persevere for our people.
Yes,
Yeah.
I woke
For the oddities. This is for the oddities.
absolutely one for the oddities. Yeah, I woke up this morning to a complete disaster. I've run out of coffee. So,
Oh no.
Oh no!
yeah, I know. I mean, what could be worse?
I've got mine running intravenously. So,
So when we finish here, the first thing I'm going to do is run down to town and get some coffee.
And I think
So anyway, this is another historic day for India. Then, hot on the heels of the landing of Chandrayaan-3 on the moon, we've got the launch of India's first solar observatory. Daz, can you tell us a little bit about this mission?
no, I didn't do any research on it.
Okay.
No, I just turned up.
Oh,
No, it's basically as Andy said, it's a solar mission. It's a telescope, and it's cram packed with lots of goodies, which are going to be studying the sun, and we'll look into that a little bit later on. Now, what I find fascinating about this mission is that there's about 6 or 7 individual instruments on there, and as expected, it's an Indian mission, but every instrument has been made by Indian companies.
Fantastic.
So this is purely an Indian mission. The only ESA are giving aid, but that's in the way of ground communications.
Right.
Anyway, this Aditya, sorry if I've got that wrong, Aditya L1. Aditya is Sanskrit for sun, which is understandable, and yeah, makes sense. And L1 is basically its final destination. It's where it's going to sit. Now we all know about Lagrange points, but for those who don't, these are orbits out in space where the gravity of the sun and the Earth basically neutralize themselves. And as we know, anything with mass will create a gravity field which will interact with anything that's in between them. Now, the best way I can think about saying this is if you remember the old type of scales you used to stand on when you were at the doctor's, stood there in your underpants, which is an image I don't want to think about. Please. And you had the scales where you had a bar in front of you with a weight, and you moved the weight along, and then it reached a point of equilibrium, and the bar would actually stay level. Well, of course, we've got the sun, which is a very massive object. We've got the Earth, which is a smaller object. So the actual Lagrange point, where it's going to be equal and everything's going to be nice, is going to be actually closer to Earth. So what you do is you move out slowly. Where the bar becomes level, that's your Lagrange point. Everything is equal. So you'll be able to park your satellite there where it will sit, and it won't be interfered with by the sun's gravity or the Earth's gravity. It will sit there. Now the L1 point, you're probably saying, well, why is it using that? It's because it's on the sun side, so it's got unobstructed views of the sun all the time. If you remember, the James Webb went to L2, which was in the other direction because it wanted the Earth between itself and the sun, because it's going to be looking outwards, whereas this Aditya will be looking towards the sun.
Can I just point out that the advantage of placing a spacecraft at any of the Lagrange points, I think there are 5, aren't there, between the Earth and the sun, if I remember rightly?
Yeah, and there's one on the far side of the sun as well.
Right, on the far side, yeah. But between the Earth and the Sun, I think we've got 5 Lagrange points. The benefit of placing a spacecraft there is that because the gravity of the Earth and the Sun sort of cancel each other out, as you say, you don't need to expend precious space fuel for the spacecraft to reorientate itself, correct its position, because it's being pulled on equally by the Sun and the Earth, and therefore you don't have to use fuel to maneuver it. Mike,
it just sat there nicely in that. But of course, as I was just going to say, if that's the Lagrange point just there, it's actually going to do a halo orbit around it. It won't actually sit at the Lagrange point, and it will just sit in this point, because the Lagrange point isn't a specific parking space, you know, because, I mean, we've already got satellites out there. It's the same at L2. All these telescopes and these satellites, etc., are all doing different orbits, so they're not going to get in each other's way. But it will be doing a halo orbit around there. So,
Michael, your thoughts about this mission?
I just think it's wonderful that a country like India are launching 2 missions in a matter of weeks.
It's amazing, isn't it?
Amazing scientific instruments as well. And, you know, first to the moon, now to the sun. That's just brilliant. Yeah.
Superb. Absolutely superb. Yes. India seems to come on very suddenly, very quickly in the space industry. And I know they've got lots of things in the pipeline. So this observatory really for them is a chance to show the world that they are serious players in space.
Yeah.
But
it's like I was saying to you, Andy, just before we started. They seem to have come up on the rails out of nowhere. Nobody noticed them coming up, and all of a sudden they've got all these missions, and they're being successful so far. Touch wood for them. So hopefully this will be successful. And now they are very serious contenders in the space race. So because they're not only just launching satellites for themselves, they're launching for other countries as well. So
and I think
of course,
I think that will.
Sorry, carry on.
I think that will continue and grow by launching satellites from the countries. Now they've been successful in landing on the moon, and with this mission as well. And also,
well, it's not a case of they just landed on the moon; they had a rover as well.
And they've also obviously built up their infrastructure themselves, and they launched control. They launched themselves, and don't have to rely on other countries for the launch. It's just good that they've got everything in house, as it were.
Michael, is there any chance you could put your microphone level up a bit? You're very low.
Go. Find it.
Or try it out.
Yeah, of course. We were talking about the moon landing, and of course that was Chandra 3, which landed. When did it land?
Last week.
A week on Wednesday.
Yeah, that's it. Yeah, a week on Wednesday. That wasn't that long ago, literally. And within hours, the little rover was off the lander, and it's been doing science ever since. And it's made some discoveries already. What elements you can find in the litho, so in the soil that's there. They're doing really well. They're doing really well.
Did you see the lovely photograph that the rover took of the lander?
Yes.
No, I was.
You'll have to look that up.
I'll have to sort that out. Yeah.
And they've been making some measurements of the temperature of the regolith, and it's a bit different to what they expected. So we will talk about that on Monday on our live show anyway.
Yeah.
So
okay. Like I said, the amount of different elements is found in the
sulfur,
the soil. Yeah, sulfur. I mean, I'm just trying to find the list now. Just bear with me. I'll find it. If you carry on, talk amongst yourselves.
Right. Okay. So we're going to have another addition to the pantheon of solar observatories, then, Michael.
That's right.
in addition to the two that are actually flying to the sun or orbiting the sun, investigating the sun at close range.
Yeah.
And there can't be enough, really, can there? Because we don't know enough about our own star. It's embarrassing, really. It's only 93 million miles away, but there's so much we don't know about it.
How many satellites are already at L1 observing the sun? I'm sure there's one or two already.
Yeah. Yes. Well,
yeah, we've got plenty of. I mean, some of these, what it's going to be studying, it's going to be studying the coronal heat mechanism, because again, we've mentioned this before. The corona, or the corona around the sun, is a lot hotter than the actual surface of the sun. So we want to understand the mechanism why the atmosphere, well, it's all like the main envelope is a lot hotter than the actual sun itself. Of course, they're going to be hoping to make looking at things so we can make better space weather predictions, which of course we need.
Yes.
There's also solar, wind, and magnetic field studies. Understanding Earth's climate as well, with reference to the sun's activity, which is something that we're concerned about at this moment, with a very active sun. Comprehensive solar atmosphere imaging, so it's going to be imaging the surface of the sun and following what's going on, and origins and dynamics of coronal mass ejections, again, which is something that can affect us.
So
there seems to be a lot of people there.
It has a big portfolio then, this mission. It's
it's going to be studying lots of things. And again, and this is something else, and maybe NASA and other people should be looking to the Indians.
Yep.
It's done, well, I don't say it's done on the cheap, but it's a fraction of the price to do these, both the lunar landing, which I think was something like $46 million, and this is something like 30 odd or something like that. I may be wrong. I'm plucking these figures out there. I know it's just a fraction of the cost that everybody else is trying to meet, but it's more power to their elbow. Hello, Rachel. It's nice to see you.
Morning.
Yeah. So hopefully it'll be. This is all going to go well, and like I said, also this science will go to, as Michael was saying, will be put together with all the other solar observers we've got going, and we'll build up a picture eventually. Because really, I mean, we think we know a lot about the sun, but really we don't know anything. Right. It's and weather predictions is probably one of the biggest things we need to be looking at.
Indeed. So launch is scheduled for about 6 minutes time.
Okay.
And a lovely day for it there in India. Obviously, there's a slight breeze, apparently, as you can see.
So I've got a list of the present probes at L1 according to Wikipedia.
Right.
Okay then.
What have we got at L1? Who's got what?
We've got the Solar and Heliospheric Observatory, which is quite an old observatory now. Yeah. The Advanced Composition Explorer, or ACE. Wind, since 2004. I'm not sure. Can't remember what WINDS stands for. And the Deep Space Climate Observatory, or DISCOVER.
Right.
So there's a few, and there are a few coming up. Aditya is the first one of 5 planned probes to go to L1. So you've got Aditya, then the Interstellar Mapping and Acceleration Probe, the NEO Surveyor, the SWFO-L1, and Vigil from ESA.
Right.
So I have to look up those and see what those are all about.
Gosh.
Yeah.
And we mustn't forget as well that as well as the solar observatories at L1, or solar observatory to be joined by India, We've also got the Parker Solar Probe, of course.
Yep.
And the European Solar Probe as well.
Yeah.
European Solar Orbiter.
We got the SOHOs. And you can actually go and look at the imagery that they're taking online. There's lots of websites, all free, and you can actually go and see what each of these individual satellites is actually looking at, and you can see it in all the different wavelengths as well, which is it's fun to do.
Absolutely.
Sorry, we're just talking about the rover on the moon. Its spectroscope instrument has detected aluminium, iron, calcium, chromium, titanium, magnesium, oxygen, silicone, and of course, as we said, sulfur. So there's lots of things to be looking at in the.
All those resources just laying there waiting around for somebody to pick them up.
Yeah,
that's right. Well, you could hoover it up because it's all so fine.
Yeah,
right.
So yeah, it's doing science up there, and it's finding some very interesting things. Of course, unfortunately, because it's at the south pole of the moon, it's a limited time expedition. Yeah, and it's only going to last a few more days because of course it can't get the sun isn't going to reach them to recharge batteries.
I was reading that India say that they will keep the mission going if the rover and lander survive the lunar night. They're quite happy to go ahead with the mission.
Oh yeah, great!
They've got the funding to do it, so it'll be really interesting in a couple of weeks' time to see whether the rover and the lander have. So there's a chance that they could survive the low temperatures of the lunar night.
Yeah.
Because in some of those craters at the South Pole, it's colder than Pluto. So
Yeah. Which was a surprise when they found that out.
Sorry?
Which was a surprise when that was discovered, that the bottom of these craters, or the atmosphere, in the craters, is colder than the surface of Pluto. Yeah, it's amazing.
Right. Is that 149, 148? Looks like it. They're launching. Oh, okay. We're going to go over to the coverage now and listen to the final bit of the coverage.
Oh, right. Okay.
ऐतिहासिक मिशन को सफलतापूर्वक संपन्न किया है, जिसमें चंद्रयान 1 और मार्स ऑर्बिटर मिशन उल्लेखनीय है। यह प्रमोशन वर्ष 2023 का 7वां मिशन होगा। इस साल की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन, GSLV Mark II का 1 और PSLV के 2 सफल प्रमोशन हो चुके हैं। यह PSLV का वर्तमान वर्ष में तीसरा मिशन है।
Here are the accused.
Or members of the jury.
Minus 1 minute.
1 minute. 1 minute to take off.
Minus 55 seconds.
Let's never forget that this represents years of work for those guys sitting there. Oh, they're expecting rain then.
हमारे साथ बने रहिए। अब
it doesn't rain in India, does it?
Minus 40 seconds. प्रमोशन किया जाएगा।
All looking good.
Minus 35 seconds.
That's clear sky there.
Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds.
PS2 VSPP open.
Minus 20 seconds.
PS on ignition RMS on.
Minus 15 seconds. 10, 9, 8, 7,
Go India.
6, 5, 4, 3, 2, 1, 0.
Straight off the pad, no messing.
Wow.
There you go.
Plus 5 seconds.
Lift off normal. P1 tracking. P3 tracking.
Oh,
magnificent lift off of PSLV C-57 with Aditya L1 on board.
Plus 15 seconds. PSLV C-57 का सफल उत्थापन और इसके साथ प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने। इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust.
I love the accents.
The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill, are just amazing. Ground-lit and air-lit strap-ons operating together with the first stage, S139.
Ground-lit strap-on separated.
जैसा कि निर्धारित है, ग्राउंड लेड स्ट्रप ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रप ऑन को यान से पृथक कर दिया जाएगा।
एयर लीड स्ट्रप ऑन सेपरेटेड।
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground lit and air lit strap-ons have been separated. S139 motor still thrusting.
S139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
प्लस 2 मिनट्स।
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
Something it left behind.
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated. Second stage has begun its operation and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
Nominal is good.
PS2 40 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
Plus 3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Wow.
There
you go.
Yeah.
The payload fairing covering the Aditya L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Oh, wow.
Second stage
There we are.
separated. Third stage ignited.
Second stage separation.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन काल समाप्त होने पर। और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है और इसका प्रज्वलन काल 117.7 सेकंड का होगा। इस दौरान यह 240 किलो न्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं, PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का। वैसा
It's
ही
the
प्रदर्शन करता
separation of the
हुआ एक
observatory
और
now, I
मिशन
suppose.
PSLV C57 का
Yeah, I think that's the last thing that
Yeah.
probably just have a quick coast and then it'll separate
For the present
the
mission,
actual.
after PS3 completes
Plus
its
6
burn
minutes.
duration,
Okay, well,
a coast phase of
keep an eye on
200
that.
seconds will follow.
So, many congratulations to India for the successful launch of the Aditya L1 solar observatory on its way to Lagrange point 1. Now, Daz, you were saying that it's going to take quite a long time to get there.
Yeah, it's going to start on quite a close orbit, an elliptical orbit to Earth, and then it appears to be it's going to take altogether 4 months. It's 125 days to reach L1, and in the meantime they'll be testing the systems and things like that. But what it is, it's going to start at quite a close orbit, quite a close orbit. And then it's going to gradually work its way out. And I think looking at the actual orbit itself, it looks as it's going to use the Earth as gravitational assist to speed up every time and get further and further out until in 4 months' time it'll reach L1, where they'll park it in its halo orbit around the Lagrange point 1.
Right.
It's 4 months in total. So it's going to take a little while. That gives them plenty of time to check the systems out, and then they can start their unobstructed observing of the sun.
It's going to be great.
So, and we hope to find out some things. Rachel did say, why does it say 6:22 a.m. GMT? Well, of course, a lot of countries. We all know about time zones. As you go around the world, we're all in different time zones. And the reason they used it, of course, GMT was the accepted as sort of like the Greenwich Mean Time was accepted as it's the same as the meridian. It's 0 at 12 o'clock. But what it is as you move around, the times changes because, of course, some people are in the night time, some people are in the day. Now, they've also got a thing which is actually the equivalent of GMT. It's exactly the same, called UTC. And what the idea of UTC is that all space agencies, but because, of course, we're watching this in our early morning, but in India, I think they're 5 hours ahead.
Something like that.
So of course, for them, it's nearly almost lunchtime. And because it caused a lot of fusion when people were using their own time zones, they didn't invent UTC, but they came up with the idea of UTC, which was Greenwich Mean Time, and the idea was for observatories and all space companies and things like that to use UTC so that everybody knew what time to be using. But of course, some people don't want to do that. So you end up with, of course, because we're not actually on GMT, we're on BST. And it was to do away with all the different variations so that everybody had one clock all saying the same time.
So
but of course, some people refuse to.
So the GMT or UT has really become an international time zone, hasn't it?
Yes, it has.
That's right. It was to synchronize. It's like synchronize your watch, so everybody could say some of the problems we have. We sit here sometimes. We say, "Oh, over there it's so and so time," and then we have to sit and work it out so that just in case we miss it.
But do you know the difference between GMT and UTC? There is a difference.
The letters.
Well spotted, Sherlock. Any ideas? You're starting conferring. Queen's College, over to you. No? Okay. The difference is that UTC uses a 24-hour clock and GMT uses...
Oh, okay then. I know what you mean, yeah.
Oh, right, okay. And also they use GMT on the space station.
Yes, they do, which is a bit odd if you really think about it.
Yeah.
But I'm glad they do.
Yeah.
Anyway, Michael, your thoughts about the launch so far?
Absolutely brilliant. Well done, India. What can I say? Onwards and upwards.
Yeah. We're now into 12 minutes into the mission, and everything appears to be going. We just saw the separation of the final stage there of the rocket, and that's obviously gone well. So there we are. So India is, or will shortly be on the way to L1. 125 days it's going to take to get there, but for presumably very good reasons, as Daz was explaining, they're going to sort of use the Earth as a gravity assist to accelerate it out to L1.
I see they're quite a good HP customer.
Yes, good advertising.
Yeah.
And well done, India, with all this going on the moon as well, and all these new elements being discovered on the moon. Well, not new elements, but
I've got to say on the 6 o'clock news on local radio, local independent radio this time, that is, I'm sure I heard them say about this launch, and they did say, I'm sure they said it's going to take about 4 months to land. Where's it going to land?
Yeah. What?
No.
I think they're getting confused with the mission a couple of weeks ago.
Is there something out at L1 we don't know about?
Yeah, an asteroid there or something.
Yeah. There we are.
Yeah, well, of course, we've got the sun in the background, so we won't be able to see it. We'll have to squint.
Yeah.
So,
if you look at it's gone. They were just showing a map of all the 5 Lagrange points.
Yeah. Okay.
So it's,
then, guys. Well, I think we will draw proceedings to a close for today.
Yeah. Well done, India.
Well done. Many congratulations, India. Well done. Thank you. Thank you for joining us this morning to watch this launch of Aditya L1, India's first solar observatory. And what can we say? Congratulations to the team. Congratulations to the engineers and scientists. And there's a trajectory look on the screen now.
Yeah.
So,
you can see around Earth there's quite a few little loops, and it's going to be moving out further and further until it reaches L1.
And there we are. So good luck to everybody involved with the mission. And we will be back on Monday, of course, with our normal live show, 8 p.m. UK time, 3 p.m. EST. Until then, have a fantastic weekend. Say goodbye, guys.
Goodbye, guys, and congratulations, India. Well done.
Yeah, definitely.
Have a fantastic weekend, and we'll be with you again on Monday. All the best.